In this next video, we are going to look at how to solve equations and inequalities that involve modulus functions. So to do that, I'm going to recommend that you always do a graph or sketch a little graph to show the equation, because sometimes if you try to just solve it algebraically, you may find solutions that actually don't exist, because the modulus graph is altering what the actual graph looks like, the modulus part. And you'll see that in some different examples. So if we want to solve modulus 2x plus 1 equals 5, what we're going to do is we're going to consider that is where the graph of y equals modulus 2x plus 1 and the graph of y equals 5 intersect. So we're looking where this graph and this graph intersect. So the first thing to do is to sketch each of the graphs. So y equals modulus 2x plus 1. So 2x plus 1 would come down, but then instead of carrying on, the bit that goes below the x-axis then gets reflected in the x-axis. So instead of carrying on below the x-axis, it gets reflected in the x-axis. So that is the modulus of 2x plus 1, and that point there is 1. Y equals 5, well, that's just a horizontal line that goes through 5 there. Okay, so you can see there are 2 points of intersection, one there and one there. Now to solve, we need to consider the equation of each of these separate lines. And I talked about that when I first introduced modulus functions. This one here, well, that's the normal part of the graph that would normally exist. So that's y equals 2x plus 1. This one, well, it's got a negative gradient and it would go through minus 1. So this is the negative version of the graph. So we are going to solve two equations, one where 2x plus 1 equals 5. That's going to give us that point of intersection where 2x plus 1 equals 5. And then we're also going to solve where negative 2x plus 1 equals 5. So we're taking both the positive version of that and the negative version of that. So that's going to give me 2x plus equals 4, so x equals 2. This one, minus 2x minus 1 equals 5, minus 2x equals 6, so x equals minus 3. Okay, so that is the point where x equals minus 3, and that's the point where x equals 2. Okay, now you might get an inequality. If you get an inequality, then you work these two out, and then you're going to use your graph to decide. Okay, so where on the graph does the modulus of 2x plus 1, where on the graph are the y values of that greater than the y values of that? Well, the y values of the modulus graph are greater than the y values of the line for that bit of graph there and that bit of graph there. Okay, so the x values that give these y values, well, that one is less than minus 3. So all these x values are less than the minus 3 there, and all these x values are greater than that 2. Okay, so if you get an inequality, you're going to solve it as if it's equal, and then you are going to apply the inequality, just like you would if you were doing a quadratic inequality. Okay, next one. So we've got modulus 4x minus 1 equals 3x. So again, we're going to consider where the graph of y equals mod 4x minus 1 and the graph of y equals 3x intersect. Okay, now these are both sloping lines. Now what is important here is that when you sketch it, your sketch takes into account the gradient of these lines. Okay, so that on your sketch has to be a steeper line than this one. Okay, otherwise you might end up with, on your graph, looking like you've got more solutions than you've got, or less solutions that you've got. You'll see what I mean in a minute. So 4x minus 1 modulus, well 4x minus 1 would look like that, ish. Okay, so it's only going to go to there, and then that is going to reflect back up, and that's going to be the 1 there. Okay, now y equals 3x is a straight line that's going through the origin, and this is not as steep as this. So what I mean is, when you draw it in, if you didn't really give it any thought and you just drew it in, you could potentially end up with that situation, where it just looks like you've got one solution. Well, the way I've drawn it, these are pretty parallel. Okay, so you might only think you've got one solution, whereas that line should have, perhaps I'll just get rid of it, start again. That line should have a shallower gradient than that line. So you need to think about the fact that this line, not doing it very well, is going to cross the modulus graph twice. Let's see if I can manage it like that. Okay, by making the slope of this less than this, we've now actually got 2 points of intersection, one there and one there. Okay, this one, this bit is positive 4x minus 1. That's equal to 3x. And this one is negative 4x minus 1 equal to 3x. So you've got to do a decent enough sketch to know which lines are crossing which lines. So this one, x is going to equal to 1, minus 4x plus 1 equals 3x. This one, x is a seventh. Okay, which looks about right. Okay, hence solve where modulus 4x minus 1 is less than or equal to 3x. So where is the y values on the modulus function less than the y values on y equals 3x? Well, that is all of this bit of graph here. So all the x values are going to be between or equal to the x values in the previous question. Okay, so you've got to do a decent enough sketch so that either you don't miss a solution or you don't invent a solution that isn't there. Because if you find an extra solution that isn't there, that shouldn't really be there, they're going to penalise you for it. Solve x modulus x minus 1 equals x. So we're going to solve where that and that intersect. So let's start with the modulus. 1, x minus 1 would come down like that and go through 1. It's going to stop there and then bounce back up like that. Okay, so that's the modulus. Now y equals x has got the same gradient but is going through the origin. So we need a graph with the same gradient but that's going through the origin, which I've just not done very well. Start that again. It's a bit better. So here's y equals modulus x minus 1. Here's y equals x. So because this is the parallel, there's no extra point of intersection there. There's just the 1 there. And that is coming from the negative version of the modulus. So x minus 1 doesn't work, but negative x minus 1. So that's that line there. That's crossing y equals x. 2x equals 1, x equals a half. Okay, so just one solution in that case. Next one, 8 minus x equals 4. So this is of the form, or this whole thing, you can think of as being that form. 8 minus x equals, so we're going to draw f of x equals 8 minus x. And we're going to draw y equals 4. Should put y. So 8 minus x, well 8 minus x looks like that. So like that. Okay, but as soon as it hits the y-axis, it has to reflect. Okay, so remember these ones only exist where x is positive in terms of the usual graph, then all of that then gets reflected into the y-axis. That's the point 8 there. Y equals 4, well y equals 4 looks like that. Okay, this one has the equation 8 minus positive x. So we're going to solve 8 minus x equals 4. This one has equation 8 minus negative x equals 4. Okay, so notice on every single one where there's a modulus, I'm solving the positive version of it and then the negative version of it. If it's the whole thing, it's the positive version of the whole thing and the negative version of the whole thing. This one, we've got the positive version of just the x and the negative version of just the x. This one's going to give x equals 4. This one's going to get x equals minus 4. Okay, so that's that point there, and that's that point there. Hence solve where 8 minus modulus x is greater than or equal to 4. So where is the y value? On here, greater than or equal to 4. Well, that's happening all along that part of the graph there. So x is going to be greater than or equal to minus 4, but less than or equal to 4. Okay, a couple more. Solve modulus 3x plus 2 equals 2x plus 3. So we're going to draw modulus 3x plus 2 and 2x plus 3. So let's start off with the modulus 1. So 3x plus 2, gradient 3, y-intercept 2, might come down like that. And then instead of carrying on, gets reflected. So that's going through 2. This one is not as steep as the previous one and going through 3. And it's also not a modulus. So we need, if you think about where it's going to go through 3, and then it needs to not be as steep, which means it's going to cross. So maybe something like that. So we've got 2 points of intersection, there and there. So we're going to solve where this one, positive 3x plus 2 equals 2x plus 3. And for this one, we're going to solve where negative 3x plus 2 equals 2x plus 3. So if I solve that, that's going to give me x equals 1 minus 3x minus 2. This one is going to give me 5x equals minus 5, so x equals minus 1. So x equals minus 1 is here, x equals 1 is here. Hence solve, modulus 3x plus 2 is greater than 2x plus 3. So where is the y-coordinate on the modulus? Greater than the y-coordinate on the line. Well, the y-coordinate, the modulus, is greater than the line. It's all along here and all along here. So all these x values, where they are less than minus 1, and all these x values where they are greater than 1. Okay, last one. Modulus x minus 1 equals 3x plus 5. So if we draw in modulus x minus 1, gradient 1, y-intercept minus 1, might look like that, but it's going to stop there and then reflect back up. Okay, 3x plus 5, steeper, single line. So this is now super important how we draw this. The line is steeper and it's going to go through 5 on the y-axis. So 3x plus 5 is going to be steeper than this line and go through 5. So it might look something a little bit like that. Okay, now you can see that there is only one point of intersection. There is no point of intersection over here. So you've got to be careful how you draw it. So if you didn't consider the fact that this was steeper, you might have ended up with 2 points of intersection. Okay, if you didn't draw it at all and solved it algebraically, you would end up with 2 points of intersection. The only solution is going to come from the negative version, the negative of that equal to 3x plus 5. Okay, there is a solution if you just took the positive version. Okay, that's the positive version of that line with that line gives a solution, x equals 3. Okay, but because it's a modulus graph, it doesn't actually exist. Okay? Because we've forced it to go up there rather than to carry on. So you've got to, if you just go through the process of solving the positive and negative equal to the line, sometimes you're going to get a solution that doesn't exist. Negative x plus 1 equals 3x plus 5. 4x equals minus 4, so x equals minus 1. Okay, so that is that one solution there. There is no other solution. This one here, if that was to carry on, that would be that solution there. Okay, but it doesn't actually exist because that's the modulus function, not just the rest of the line. So you must sketch the graph to make sure you don't end up working out extra solutions. Hence, solve. Modulus is less than or equal to the line. So where is the modulus function less than or equal to the line? Well, it's all of this bit here. So that is where x is greater than or equal to minus 1. And that's that. Okay, so just get into the habit. If you see a question that looks like that, even though it won't tell you to solve it using a graph, just get into the habit of sketching the graphs. Okay, practice 2A, questions 2, 3, 5 and 13. And that's the end of that video.